Vertex form of quadratics today. This is our second lesson on quadratics. So our vertex form, if you remember, is y equals a times x minus h, the quantity squared, plus k. So it looks a lot like our vertex form for absolute values. The only difference is for quadratics you have parentheses and a squared sign, whereas with absolute values you just have the absolute value symbols. Our parent function is just y equals x squared. So it's very similar, and we'll be doing the same thing all year for all the different functions. They all have the similar format. So our attributes, our a value is our leading coefficient. The leading coefficient, it compresses or stretches. Compresses or stretches. It can also reflect if it's negative. The h, remember, is the opposite sign of the inside value. Or remember, x's lie to you. The x's lie. So it's opposite sign of the inside value. H always is horizontal, left and right. And our k value then is our ending constant. That just means it's a single number. It's our ending constant, and it stays the same. If a is, and some of this you know, a is positive, the parabola opens up and we have a minimum. So that means we have a graph that looks like that, and at the bottom is our min. If it's negative, it opens down and it has a max. So it looks like this. So negative flips it across the x-axis, reflects as we would say. Our vertex is always at h, k as our coordinates. And our h identifies, so think of it as the x value of the vertex that always identifies your axis of symmetry. Your axis of symmetry as x equals h. And our k value, it just identifies the max or the min. So it identifies your maximum or minimum. To graph the parent function, you must square your horizontal movement. So if we think about that, so left and right we move x, and here we move y. So whenever I'm graphing, whichever way I move, so when I'm graphing and I move right of the vertex 1, 2, or 3, I always have to square my vertical movement. 1 squared is 1. 2 squared is 4. 3 squared is 9. So that means when I'm moving 1 point to the right of the vertex, I move up 1. When I move 2 points to the right of the vertex, I move up 4. When I move 3 points to the right of the vertex, I move up 9. And when we have an a value, so like here, we have 6x squared. We have to multiply your vertical movement by a. So here's x and y. This part is going to always be the same. It's going to be 1, 2, 3, 1 squared, 2 squared, 3 squared. But then in this case, we have a new y value because we have to multiply by a. 1 times 6 is 6. 4 times 6 is 24. And 9 times 6 is 54. So that's how much it moves when you are stretching it like that. Vertex shift. So remember, horizontal is opposite. It's lying to you. So to move left, we're adding. To move right, we're subtracting. So if you look at this graph here, our normal graph, our parent function graph, looks something like that. This graph here shifts to the right 3. So it moves everything to the right 3. Shift right 3. And when we're graphing these, we always want to graph our parent function first. Vertex shift, this one stays the same. So up is positive on the outside, down is negative. So once again, now we have x squared minus 3. Parent function still in the same spot. But now we move down 3 units. And it's the same graph, just shifted down. So you can see how this is very similar to what we did with absolute value graphs. Everything is the same except now we just have a U-shaped graph and this part here. Right here, that part is a little bit different because now instead of having a slope, we have to move it up with the square root. Okay, let's flip over our page and look at some examples. Okay, so right here, we're going to look at a few. So you can see on these first ones, we have the parent function already drawn in. So x squared plus 2 means it shifts up 2 units. So that means our vertex is at 0, 2. So when you're graphing, always find your vertex. And then you can make a table. And we always remember 1, 2, 3, 1, 4, and 9. So now from my vertex, I'm going to move right 1 and up 1. I'm going to move from my vertex, I'm going to move right 2 and up 4. And from my vertex, I'm going to move right 3 and up 9. So I'm just off. So that means this graph is going to look like this on this side. And then remember, because they're symmetrical, we have points on the other side at the same spot. Points match up, even though I can't draw them very well. So on either side of the axis of symmetry, and remember your axis of symmetry is the x value of your vertex. So in this case, it was at x equal to 0. This dotted line was my axis of symmetry. If I look at number 2, I have x minus 3, the quantity squared. So in this case, I'm shifting right, because x's lie, right 3. So my vertex is going to be right there. I'm going to be doing the same thing. That means my vertex is at 3, 0. So you can see it. And then x and y, because I don't have an a value, I don't have to make a new y. So it's just going to be 1, 2, 3, 1, 4, 9. So I move 1 to the right and 1 up. I move from the vertex 2 to the right and 4 up. And then I move 3 to the right and 9 up. Then I connect the dots. My axis of symmetry is at x equals 3. And so then I can just make my other points on the opposite side because it's symmetric. And we want to make it U-shaped. So there's the first two. Alright, let's look at number 3. This negative sign tells us that it reflects. The negative out front reflects across the x-axis. That is our transformation. So what that means is our vertex did not move. The vertex is still at 0, 0. But now we're going to have a new y. We have x, y, and then new y. So 1, 2, 3, 1, 4, 9, and now we need to multiply by a, which is negative 1. So this means our new y is negative 1, negative 4, and negative 9. So when we move 1 to the right, we move 1 down. When we move 2 to the right of the vertex, we move 4 down. When we move 3 to the right, we move 9 down. So that's that side. My axis of symmetry is still x equals 0 because of my vertex. And so then I can just do the same thing on the other side. And so my graph flipped upside down. It reflects across the x-axis. All right. Okay, so for number 4, we have y equals 1/2 times x squared. That 1/2 is our a value. Because it's between 0 and 1, we say it compress. You compress by 1/2. So when I do my table, I have x, y, and new y. Well, so if I can slide it over for you to see, still 1, 2, 3, 1, 4, and 9, and then now I multiply it by 1/2. So 1/2, 2, and 9/2. Those are my new points. So my vertex is still at 0, 0. Now when I move right 1, I'm only going up 1/2. When I move right 2, I'm only going up 2. And when I move right 3, I'm only going up to 4.5. So my graph is going to look something like this. It's a little bit wider. My vertex, or my axis of symmetry, is still along x equals 0. And so then I can just match my points. So it gets a little bit wider. So when you're graphing, I need to see your points. I need to see your points that you have selected when you're graphing. And then I'll leave number 5 to you. Just know that there's 4 different transformations on number 5. So this one I want you to try by yourself. Okay? And that is our quadratic graphing with vertex form.